There we go. So it looks like we are live. Um, cool. Well, thanks everyone. So Wednesdays it is. Next week I think I'm double booked. So I'm not sure I will be able to make next week on the Wednesday. But that's fine. We can sort that out afterwards. And I can always catch up after the fact too. But let's maybe start if folks have quick updates or things you want to pose for longer discussion after that. Let's go for it. So I see John in my view first. So you can
yeah, no worries. I'm not too much ahead on most stuff here. I've started the testing the parallelization with Dask over the frequencies for the MT. I don't really have much to show for benchmarking or anything yet, but next week I'll have some good numbers and something to show a little bit. Oh, the pull request for simulation JK, I checked and it's failing in all the same places as the regular simulation branch, except for on the second one, or the second tests. It seems that the simulation branch is breaking on the test flow where mine is passing, and mine fails the TDEM, but it passes on the simulation. So that's the only difference I see between the two branches.
Okay, cool. Well, we can take a look and maybe try and get that in like later this week or early next. Are there any things like, I don't know, in the code, are there any questions, or is it worth doing a quick pass if you have any questions and just like go in and tag? Do you know how to do that in the pull request?
Yeah, I saw that, but I did in a few places, but everything that I tagged, I kind of figured out.
Okay, excellent.
Yeah, seems to be good. The one thing that I did also is I brought in Dom's changes to the regularization.
Okay.
So that's in this branch too. Yeah, I guess it was trying to keep it small and simple, but I wanted to try it out, see what it was doing. So
that's really fair. That what I can try and do is maybe merge the regularization into the other one too. Well, I'll take a look. I think it's also fine to just like merge this in and checkpoint and kind of keep going.
Okay, cool. Yeah, it should be pretty much ready to go. I can take a look into that, why it's failing on the TDM, but that's it.
Okay. I think that actually might entirely be my fault as to why it's failing on the TDM.
Oh, yeah, there's an error, something that it wants some kind of points, or the shapes are different. Something like that. Yeah, I can post it on there. Yeah.
Okay, that sounds good. I think that might be my bad.
Fair enough.
Cool.
Yeah, other than that, maybe a discussion afterwards. We were looking at changing the objective function, maybe adding like a Durbin-Watson. It was Alan Jones gave the paper at the SEG a while ago, and my higher ups there are wondering if we can start implementing that. Yeah, something I might try to do here in the future. But
what is it?
Adding the Durbin-Watson statistic to the objective function. I can send the paper. I can post the paper there. But it's just he kind of points out that it's a better judge at fitting the data, whereas just the chi-squared, you can it's a little bit more wiggle room, whereas the Durbin-Watson might push it better. Yeah, I'll post it on Slack there if you want to read that.
Correct me if I'm wrong, but I think for that measure, basically what it measures is that it tries to avoid the correlating noise. So it tries to make sure that the normalized misfit looks random, kind of a measure of that. Is that what it is?
Yeah. That sounds about right. Yeah.
Yeah, I think it looks at sort of basically how it tries to balance how many values are above and below 0 or something like that.
Yeah.
Yeah, if you have the paper, that would be awesome. And that's something that that should be pretty straightforward to add. Now, you would be adding that to the objective function, right? Not replacing phi d with it.
Yeah, exactly. It would just be adding it to it. And yeah, I guess that it would just be another kind of a misfit function of some sort, or it wouldn't involve combo objective function or anything like that, right?
Well, so the implementation wouldn't require that, but then, or like the implementation of the Durbin-Watson statistic won't require the combo objective.
Okay.
But then when you actually want to use it, then you would be adding together two data misfits. So you have your one with respect to the data misfit and then the Durbin-Watson statistic. Now that I'm saying this, though, the thing that I am thinking through is that if you include both of those data misfits, you actually need to solve, like we're solving the physics when you do the Durbin-Watson, and you're also doing derivatives, you're doing gradients on that.
Yeah.
So we actually are probably going to have to put some thought into how to thoughtfully combine those, because if we just naively do what I just suggested, if you add those two things together, we're going to end up solving all of the physics twice.
Oh, no, yeah.
And so that's not what we want to do. So we'll have to think through that. But as a first pass, I mean, just implementing the function, I think is totally fine. And then we can figure out how do we actually like wire these things together so that they're not, we're not duplicating solves.
Solves, yeah. Okay, cool. Yeah, yeah. I'll get a first pass going here soon, and we'll go from there.
Cool.
Nice. Should I just post that on the meetings or in general? Does it matter? Or
either or.
Okay. Yeah. Other than that, just still working away, hacking away at things.
Yeah, John, I was just going to ask what geophysical methods you're covering in your PR. I know there's MT in there.
Oh.
DC resistivity is there.
I've kept I haven't pushed any of the MT stuff yet. So the simulation JK is just DC and IP for right now.
Okay, yeah, no, that's great timing, because then I can take a look at some of the examples and try and get something to that as well, tutorial.
Nice. Yeah, so got the MT forward simulation example going too. I'll have to send that on to you there. You can take a look. And that's just running with the regular, what's already in the simulation. So there's no, you don't have to download the branch. You just, if you're on simulation, you can use it.
Oh, that's great.
Thanks, John.
Yeah.
Do we want to go around the table at UBC?
I don't have too much to say other than did a student contacted you? John, Roshi, she's on a Slack channel.
Yeah, I saw the message on Monday there. She hasn't got back to me. Yeah, I told her I'd be open to it and be all good. She didn't really go into too much details other than she was interested in solving the MT problem for a mesh for each frequency, I think.
Well, I pitched that to her because she wants to code something for her thesis and she wanted to do MT. So I was like, well, you should talk to John because you're the one that is like elbow deep in it right now. So yeah.
Cool. Yeah, I can keep you posted on where we go with that. And yeah, she contacted me. So there's a start.
She looks sharp. Yeah. Well, I heard that out for at the beginning for potential fields, but now she wants to move to EM. So I don't have the bandwidth to be able to do that.
Fair enough.
Yeah. So yeah, after our conversation last week, Sagi showed me how we could use Paradiso inside Dask to solve the issue with the random float errors that we're getting.
Oh, nice.
So we might try it. I might try it on your branch, John.
Okay.
I'll branch off and then just see if we can do that, because that way we wouldn't have to like store a bunch of Dask and collect them at the end. We could do it all in parallel.
Nice.
And I think for the tiled code, we'll need Paradiso to be inside, because all the forward model is going to be done in parallel, right? Anyway, I'll try it and I'll talk to you.
Okay, cool.
Yeah.
Cool. And just one quick comment for the student. Sorry, what was her name?
I just know her. Hold on one sec. I'll find her handle.
Roshanak.
Yeah, Roshanak. Yeah, Roshanak. I don't know her, but she's in Sweden. Yeah. Iranian name, eh? Yeah.
Well, I mean, feel free to invite her to the meetings. I realize this time won't work well for someone in Sweden because it's like the middle of the night there, but we could always move a meeting if she is interested in connecting and giving us a bit of a sense of like what she wants to do, and we could do a bit of a group brainstorming. I mean, that I think would be productive for all of us if she's game to actually be playing around with multi-mesh stuff in MT. That would be huge for the project. So
yeah, her local time is 11:15 p.m. No good.
A little late.
Yep.
Yeah, but we can definitely move a meeting, and if she wants to show up regularly, we could start alternating or something like that, because yeah, it'd be awesome to loop her in.
That's it for me.
Not much to really update, except we've been working on the Myanmar stuff. I think the good news is that we've heard back from them, and we're definitely on. So we will start teaching there on the 28th for teaching training for 2 weeks. So we're organizing, all the equipment to get to Myanmar, and then we're just putting together both slides and notebooks that can be used. So the notebooks will be, in addition to what we have already on GeoSci, on GeoSci Labs, some of the ones that demonstrated DC resistivity. Then we've got, for 1D soundings, we've got both a forward modeling and an inversion, so we can do both synthetic and field data. And then the same will be true with the 2D. So Lindsay and Sagi have developed both of those. There's a few more tweaks and things to do, but I would actually hope that by next week, maybe we'd be able to try to do a demo of them during this time. If there's just to kind of see, what everybody thinks, and also a bit of practice for ourselves just in running through the data set. So I think that we might try for that this week.
Sounds good. You're the gonna demo it?
That would be interesting. We should do that.
That sounds good to me.
I don't have anything new outside of offering Bren some assistance, but I'd like to, in the near future, continue coming up with some tutorials based on the stuff we've done on the simulation branch. So I'm spending a little bit of time chipping away at that, but I don't have anything new over the past week.
G?
Yeah, nothing new really. Like working with the MBI code, still adding logarithmic scale and all that type of thing that makes it super non-linear and super unstable at the moment. So I'm still trying to find a way around that. But then I got to figure out jump again.
And give us a tour.
Can you repeat that first part? What are you working on again?
So I'm working with the MBI code, but in not the Cartesian, the spherical coordinates. And I'm trying also to put the amplitude in log scale, so I have like an exponential map on that. And the MBI spherical is super nonlinear, and adding the log scale just make it kind of like go crazy or either go crazy or go nowhere, but nothing in the middle so far. Like we tested with them, like even like the spherical code, even like with just like identity mapping with no log scale at all. But if you starting from a hat space, you don't get anywhere. Like so, Dom is using, for example, the Cartesian code output as a warm start for that. But then when I'm adding the log scale on top of that, that's not enough anymore. So I need to find some way to go around that, because I'm working with the petrophysics, and the petrophysics is definitely more workable with in the log scale. So there is like some balance to find between what the code is able to handle and what the type of information we want to put in.
Thanks, Thibault. Mike or Vahid, do you have either of you have updates or things you want to pass on to the group?
Not just with, I've got some good results for the central part inversion of the gravity data and data in Dallas region. I think I hope so that's the last final, not
Revision.
last final results. No, actually we switched to the complete part, say 200 kilometers, 200 kilometers, it's very big area. The gravity data is actually fresh, and it's the first time that we want to model it. And the most important aspect that in this region is that we have 5 kilometers grid spacing. So actually we should detect the basement of the Zagros Mountains by this SimPEG inversion code. That I think this is the first time that somebody is using it for the basement, not just for the compact inversion. And we are trying to use the script that provided actually by Ron. Changing the mesh and also the norm, the regularization norm to get this depth is very difficult because it's about 15 to 20 kilometers displacement. And in this area, 200 kilometers to 200 kilometers actually a very important information that everybody is looking for the basement depth in that area. And now several papers, of course, with other geophysical methods, seismic or magnetic or airborne magnetic use for displacement. And this is the first time that we are using gravity data through SimPEG, and this is just for the basement, not just for the compact inversion. That's how we are trying to solve it.
What kind of applications is that basement useful?
Yeah,
What kind of applications?
you know, the whole area of the Zagros is important at the source, the oil and the gas, the servers. In this part, the geothermal resources actually. This is the area that in the central we have the geothermal system. So everybody is using this basement or say the geothermal resources for in this region. But in addition, there may be some other interest in this region, especially for petroleum and other resources.
I don't have too much to add, just writing, editing, trying to finish up a couple examples.
Excellent.
The floor is yours.
Oh, well, Ren, do you have any updates? I know Doug.
Not really. I think Doug pretty much spoke for me. We're yeah.
On track.
On track. And how are things going? Sort of running the apps. Are you like with what's going on?
Yeah. So the Soggy's 2D DC app. It was running fine for, I tested both a field data set and a synthetic data set, and yeah, they were both outputting results. Yeah, we're actually trying to, there's that 1D notebook that you provided a while back. I think it was called Untitled, but yeah, but that had the both for modeling and inversion. So yeah, we asked Soggy if he could kind of make that into something like the 2D notebook, or like pretty much identical, actually, just 1D versus 2D. Yeah, so I think he's working on that now. Yeah, so thanks for providing that.
Yeah, we're happy to.
Yeah. Yeah, I think that's all.
All right. I can give a couple quick updates from my end. I've been still playing with SimPEG up on NERSC, which is the supercomputer up at LBL. Sort of getting a bit more familiar with how to efficiently use Dask to basically spin up like a whole bunch of simulations. And so right now that's just requiring like thinking through sort of file structures, what is being written out, making sure that all of our classes serialize properly. And so I actually ended up submitting a small pull request to properties so that if we want to save stuff to HDF5, we can. And we can also like get it back from HDF5. There were a couple subtle things with the way that they save, or the way that HDF5 saves Booleans, and like they don't, they get round tripped as NumPy Booleans, which is fine. But properties wasn't expecting that to be incoming. So we got that sorted. And then I also gave a short presentation here on Monday. I'll drop the link into the, it's in the meeting notes, but I'll drop it into Slack too. This was like very much a sort of informal presentation. But it was to the ML and physical sciences reading group here. So there's a group maybe of, I think there were about a dozen people there on Monday, a lot of folks in the Astro community who are looking at using machine learning for different parts of their workflows. And so I gave a short presentation on how we're thinking about potentially using machine learning in the casing problem. And so to try and estimate some sort of like correction term, basically, if we run an approximate simulation, we know that the solution is going to start to break down, but can we use machine learning to basically give us back a correction factor? And so there were some cool conversations that came out of that. And so I got chatting with another postdoc here who's in Astro, but doing a lot in stats. And he's actually also extremely interested in inverse problems. And looking actually at uncertainty in inverse problems. And so he has some ideas about how to potentially use design a regularization term that then gives you out sort of probability distributions on your model at the end. And so this is something like I still don't have my head entirely wrapped around, but I created a small example just from the linear inverse problem example that's in the example. So thanks for that, Dom. And so he's going to start playing, and so I'll keep everyone updated on what comes out of that, and if there's some interesting new sort of regularization things that we could be thinking about. So yeah, that's kind of all for my updates. Are there questions or things that people would like to dive into in a little more detail with what time we have left?
I just want to add that it works. The installation of Discretize on Windows and SimPEG EM1D no longer requires the Fortran and the C++ compiler, so this is amazing. It reduces the installation time by, I don't know, 6 gigs or something. So that's great. Thank you again, Lindsay. This is huge for us.
Excellent. So that's the Conda installation?
Yeah, so just need to tweak a little bit the SimPEG EM1D installer so that the Conda installs SimPEG instead of pip, and then through Conda, then Discretize gets compiled. And then the Fortran compiler comes straight from NumPy now because they're handling the Fortran thing. So yeah, we're good.
Excellent. And is SimPEG EM1D, is it up on Conda Forge yet?
No, pip only.
Okay. That's actually something that, like, if you want to start, it's reasonably straightforward, and the Conda Forge folks are like extremely helpful. So even if we do it wrong at first, they will jump in and help us out. So if anybody wants to like take charge on that, I'm happy to point you to a few links to at least like take a crack at it, and then I can send you the names of people to reach out to.
I guess that's a question for Sag, but is there a reason why SimPEG EM1D is separate from the main framework?
I think in part because he wanted a space to just explore and get that up and running. I think that's something that we should talk about and see if we think that fits within SimPEG, or maybe pieces of it fit inside of GeoAnna actually. Because in some senses it's like SimPEG right now is scoped to be mostly finite volume based things. Yeah, but it would be nice to have a deeper connection between the two, and not have it be like a separate package if that's what he wants.
Yeah. Sounds good.
Cool. Okay. And are there any other pull requests or things that are, so we've got John's one is on the list for taking a look at and getting checked out. Is there anything else that people have that like should be sort of raised on the SimPEG collective to-do list?
I need to finish the PF. I mean, now that Thibault tested the gravity gradiometry, and we have both the mag and graph, symmetric. So
yeah,
we should I need to find the time to finish up.
Yeah, I have this spherical map one that's here, but it's failing at some tests and haven't spent the time to figure out physically what's happening there. But that will go with the PF at some point too. Like yeah.
Well, that needs to be that's directly onto masters though, right?
Yes, so this one like can work directly on master. It doesn't need your PF branch, but some of the tests are failing and I haven't figured out why yet.
Yeah. Okay.
So that's
good. Well, I guess we can wrap up early. The thing I did just want to check with folks is if we could potentially move the meeting next week. I'm just pulling up my calendar because I had agreed to go be a guest lecturer in a course here. They're doing a data science. It's like a module course, so it's a small course for honors thesis students. And so it's a course on like reproducibility and like open science practices. And so I was going to go talk about some of the practices like that we've had in the SimPEG research group with respect to like managing and distributing notebooks and stuff like that. But I am signed up and can't get myself out of that one. If we could bump it up an hour, that would work with me. But if not, then I can also just catch up with everyone afterwards.
I'm cool with one, no problem.
Sure, no problem.
Okay.
Yeah.
I appreciate it.
1 o'clock.
All right. Sounds good.
Yeah.
Any last burning items before we wrap up a bit early today?
Or remain silent forever.
All right. Yeah.
Until next week.
See you guys all next week. And I look forward to seeing some demos from Ren and Doug.
Well, there we have it.
Indeed.
Right. You wowed and dazzled.
See you guys.
Bye.
Bye, guys.
Take care.